अस्सलाम वालेकुम वरहमतुल्लाहि वबरकातुहू। मैं उम्मीद करता हूँ कि आप सब खैर खैरियत से होंगे। आज हम अपना लास्ट चैप्टर जो है तो वो हम स्टार्ट करने वाले हैं। दैट इज द चैप्टर रिगार्डिंग द डिस्ट्रीब्यूशन सिस्टम। जिस तरह आपको इल्म है कि यानी वी वर दिस जो सब्जेक्ट इज रिगार्डिंग द इंट्रोडक्शन टू पावर इंजीनियरिंग। तो पावर इंजीनियरिंग के या पावर सिस्टम को अगर हम देखें तो पावर सिस्टम है द नंबर ऑफ फेजेस। एक जनरेशन फेज है, फिर जो है तो ट्रांसमिशन का है, फिर डिस्ट्रीब्यूशन का है, और फिर एट द एंड जो लोड है यूटिलाइजेशन है। तो इसमें इन द बिगिनिंग जो है तो हमने यानी पावर जनरेशन जो है तो हमने स्टडी किया। फिर जो है तो हमने यानी उसके मुख्तलिफ चीज़ें जो है देखी। फिर हमने पावर के लिहाज से जो है तो कुछ डिस्कशन की रिगार्डिंग द रियल पावर, रिएक्टिव पावर, कॉम्प्लेक्स पावर, ये सारी चीज़ें। फिर जो है तो हम इलेक्ट्रिक सप्लाई सिस्टम की तरफ आए। इलेक्ट्रिक सप्लाई सिस्टम जो जनरेटिंग स्टेशन को जो है तो कंज्यूमर्स के साथ जो है तो कनेक्ट करता है, या पावर जो है जो डिस्पैच करते हैं फ्रॉम द जनरेटिंग स्टेशन टू द कंज्यूमर। तो उसमें दो मेन सब सिस्टम थे, एक ट्रांसमिशन सिस्टम और एक डिस्ट्रीब्यूशन सिस्टम। तो आज आपका ये चैप्टर जो है चैप्टर 12, ये फिर डिस्ट्रीब्यूशन सिस्टम जो इलेक्ट्रिक सप्लाई सिस्टम का जो सेकेंड सब सिस्टम है, दैट इज द डिस्ट्रीब्यूशन सिस्टम। तो उसकी फर्दर जो है तो डिटेल है इस चैप्टर में, तो हम वो इंशाल्लाह इसमें स्टडी करेंगे। तो अगर हम स्टार्ट करते हैं। मैं लिख देता हूँ, दिस इज चैप्टर नंबर 12। चैप्टर नंबर 12 डिस्ट्रीब्यूशन system, and this distribution system is from the book of I would say V.K. Mehta, a book by V.K. Mehta। ठीक, तो चले इसको थोड़ा सा मैं आपको एक ओवरव्यू दे दूं कि what we studied in the last chapter, that was the chapter regarding the electric supply system। और फिर इसको हम जो है तो हम इन डिटेल स्टार्ट करते हैं। हमने ये स्टडी किया कि कोई भी इलेक्ट्रिक सप्लाई सिस्टम में आपके पास जो जनरेटिंग स्टेशन हैं, यानी जो जनरेटिंग स्टेशन हैं, उनको हम कनेक्ट करते हैं विद द कंज्यूमर्स। तो लेट सपोज अगर मैं कहूँ इफ दिस इज ए जनरेटिंग स्टेशन, तो ये जनरेटिंग स्टेशन जब वोल्टेज प्रोड्यूस करता है, लेट सपोज अगर मैं कहूँ कि दिस प्रोड्यूसेस generates the power at 11 kV, so then we need to step up this voltage for the sake of transmission. So then we will have a step up transformer connected here. Now let us call this transformer, step up transformer is 11 kV to 33 kV step up transformer. So now if I say that this is I would say that this portion of the electric power system is basically, you can say this is a generating station, or you can say this is a generating substation. From onwards this generating substation, if I change the color, so I will have, अगर इसको मैं थोड़ा सा ठीक कर दूं, सॉरी, from onwards this generating substation, if I change the color, तो ये जो है जो the line in red, then this is the transmission system. I would say this is the transmission system. I may represent this by TRS. And we know this here that this transformer is basically a delta star connected transformer. With the star, neutral is grounded. See? So now let me represent this transmission line. This whole diagram is a single line diagram, although the system is a three-phase system. But I am representing this system by a single line. So from this generating substation, I have the transmission system. और ये ट्रांसमिशन सिस्टम फिर आपके पास है थ्री फेज और थ्री wire system. This is connected in star configuration with the neutral grounded. We already discussed that what are the advantages of these transmission lines, the three-phase transmission line connecting in star connected. तो इसके बाद ये ट्रांसमिशन रन करता है towards the transmission substation. If I draw a transmission substation, so what happens in the transmission substation if I represent this box with a transmission substation? So this is transmission substation. Here the voltage rate is 33 kV. That is the therefore the transmitting voltage 33 kV. So this 33 kV is stepped down into 11 kV by a step down transformer. 11 kV. Right now, from onwards of this transmission substation, if I further change the color, या इधर हम देख सकते हैं कि from this whole red system, this is included in the transmission system, right? Now from onwards this transmission substation, I will have the distribution system. Here the voltage will be 11 kV, and this is connected in delta configuration, or this will be three phase. This is three phase and three wire again, because we do not have any neutral in the delta connection. Now this is the 11 kV feeder, and this is known as the feeder. Feeder is a line that basically connects the transmission substation with the distributor. No, sorry, not with the distributor, with the distribution substation. Now this feeder ends in a distribution substation. I will say the distribution substation. Now let me represent this by D dot S. This is a distribution substation. Here the voltage is further stepped down from 11 kV to 400 volts. Now here the voltage that I'm mentioning is basically a line voltage. This is not a phase voltage. This is a line voltage. From this distribution substation is basically the transformer that is located outside your homes. So this is basically a transformer that is located outside your home. Now let me represent this. Mention this. This is basically a transformer that is located outside your homes in the residential area. Now from this transformer, we have basically three wires. Now let me representing. Again is represented with a single line. So this single line is basically now three phase and four wire. The three phase, three wires constitutes the three phases, and the fourth wire is basically the neutral. And this transformer is delta star transformer. We already studied that why this is a delta star transformer, because here if you want to take a single phase supply or three phase supply, so we can take it from the these lines, and these lines are known as distributors. As this line is called as feeder, so these lines are called as distributors. right? And now from this distributor, we will have the service mains, and the consumers will be connected to these distributors. Now let me represent by C1. This is consumer 1. This will be consumer 2, and now this will be consumer 3. This line that connects the consumer with the distributor is known as the service main. This is the service main. Normally here in our country, this is known as basically a service wire. You can also say this is service wire, or this is known as the service main. Or you can also call it as a service wire, or simply you can also call this as a service. Right. So this is basically the system, the power system. So the first in black is the generating end, then the second phase is the transmission, and then the third in the blue is basically the distribution. So now this is the distribution system. You see that the one in blue color is basically the distribution system. So now this is the system that we will study in this chapter. And if I now define this distribution system, so from this diagram I can define the distribution system. I can say that the system that distributes the electric power for local use or among the consumers is known as distribution system. And further I can say that the system, generally the system means the distribution system exists between the transmission substation, the substation that is located in the vicinity of the city. So here the one in red, the 33 kV to 11 kV is basically the transmission substation. So generally this system exists between the transmission substation, and the substation where the transmission line terminates, and the consumer meters. See? So this is another point that is added to this system. So this is basically the definition. Now let me highlight that this is the definition. Okay, the power, the system that distributes the power for local user among the consumers is known as distribution system. And further, we can add a point that this system generally exists between the transmission substation and the consumer meters. Okay? So now we will study about this system, basically here, the distribution system. And we have already studied that why we need basically the distribution system. The reason we need a distribution system is that we have different types of consumers. Like I will mention here, that we have different types of consumers, like the consumer, like industrial consumer, one, right? Then here comes the commercial consumer. Third, we have the domestic consumer, right? So for the industrial consumer, the voltage that is delivered to the industrial consumer is basically 11 kV, and then they further step down this voltage according to their need. The commercial consumer normally the voltage it requires is basically 400 volt, a three-phase 400 volt, and the domestic consumer depends. It needs some can use the voltage single phase, that is 220 volts. 220 volts, or maybe a three-phase connection of 400 volts. So due to these different requirements of the voltage, we need to distribute these voltage among the consumers. So this is the main reason of the distribution system. So now from this discussion, if we just go back to this figure that I draw again, so I can mention here. That a distribution system basically consists of the following the three main components. I can write here that a distribution system mainly consists of three components. If I name them, the first is known as feeder, the second is distributor, and the third is service, or you can simply say it as a service wire. Now, if I say what is the difference between them basically, so the feeder, if you see from this figure, so the feeder is the connection that basically connects the transmission substation with the distribution substation. And normally here in our country, the voltage of the feeder is 11 kV, and this feeder is connected in delta configuration, means the three phase and three wire system, the delta configuration. The feeder is basically something that we do not take any parallel connection from the feeder, that is known as taping. So let me explain the taping. That in case of feeder, we do not take any tapings, or you can say the parallel connections. For example, if I say if these are any two poles, and for example, if a feeder is running along them, a three-phase feeder that is in the form of delta connected. So the voltage here at the feeder is the line voltage basically is 11 kV. If I want to maintain this 11 kV voltage, so I can simply take a parallel connection from this. If this is feeder 1, so I can take simply a parallel connection from this feeder. So this will become feeder 2. So this parallel connection is basically known as taping. This parallel connection is basically known as taping. And in this taping, when you take a parallel connection, so definitely the current in these feeders will get divided. So when the current in this feeder gets divided, so definitely you will have a low value of current. So the main requirement of the feeder is that the current should remain the same. So in the feeder, the current should remain the same. Therefore, we do not take any taping in the feeder. So we do not take any parallel connections from the feeder. So this is the main understanding regarding the feeder. So the feeder is something we are transferring from the transmission substation to the distribution substation. It is normally connected in the form of delta, and we do not take any tapings in the feeder because the current divides due to the taping. The second component of the distribution system is basically the distributor. So if we just look at this figure again, now if we look at this figure again, so I will consider this distributor. So distributor is something that runs from the distribution substation, or you can say the transformer that is located outside your home, runs from that and onwards. So this distributor, if I draw here on the poles, for example, if I have a pole, so you see that the feeder actually was running. If I just go back, so the feeder you can see here, the feeder you can see that these lines are basically running horizontally. These lines are basically running horizontally. Here, these lines are running horizontally. Now, in the case of distributor, so if the distributor is something that connects the distribution substation, or you can say the transformer that is located outside your home and moves forward, or you can say it connects the distribution substation transformer and the service main basically. So that is known as the distributor. So now when if I explain the distributor, so it's somehow like this. Uh, you see, this is basically the distributor. It connects the distribution substation and the service means of the consumers. Now these distributors, unlike the feeders, they run vertically. If I draw two poles, this is pole 1 and this is pole 2. So these distributors is basically a three-phase and four-wire system, and this is connected in the form of star. I would say this is connected in the form of star, or you can say the Y connected with a neutral line running. So this is a three-phase. This is a three-phase and four-wire system basically. Three-phase and four-wire system. Now the line voltage here at the distributor is 400 volts. As the distribution substation, or you can say that the transformer, has stepped down the voltage from 11 kV to 400 volts. So now the arrangement of the distributor is somehow like this. They run vertically. So if this is phase A, so this will be phase B, and this will be phase C, and here is the neutral line. Now the reason of this distributor to connect this in Y connected is and having a neutral, not earthing the neutral basically, and having a neutral wire. The reason is that if you want to take 220 volts, 220 volts means a single phase connection. So you can simply take it from a single phase, phase C, and then a neutral. So this here the phase voltage will be basically 220 volts, and this connection is known as a single phase connection. This is 220 volts, and its connection is single phase connection. Like I can give you the example of my home. In my home, we have a single phase connection of 220 volts. On the other hand, if you definitely would have heard a three-phase meter. So a three-phase meter is basically the one which is connected with a three-phase lines. I mean, जो distributors हैं उससे basically three-phase connection जो तो input होती है into the meter, and then a three-phase back into the from the meter back to the home. So the three-phase connection will be somehow like this: that from phase A connection, then from phase B, then from phase C, and then from a neutral. So the line to our line voltage here will be then 400 volts, and this will be a three-phase connection, three-phase and four-wire connection. So the reason of this distributor to connect this in Y connected with a neutral is that to take single phase and three-phase connections. Now the third component in a distribution system is basically the service main. You see, if I describe you the service main or explain you the service main, so it is somehow like this. If I just rub this figure, and I draw this figure again. You see, I explained that the distributor is somehow like this. If we have phase A, they are running vertically, means vertically to the earth, to the surface of the earth, and horizontally again to the surface of the earth. This is phase B, and this is phase C, and this is a neutral line. Now, if you want to take a connection from this distributor, so to connect the consumer to this distributor, so it will be somehow, if we take a single phase connection, so this is phase C and this is the neutral. So you see this phase, if you want to take a single phase connection, one phase, तो ये एक phase जो है तो हम connect करते हैं जो है single phase meter, and then from the meter this single phase is outward and into the home, or you can say the consumer one. So you see the connection that connects the distributor to the consumer's meter is known as the service name. Now this is the service name. Now let me represent it by S, and this is the service name. On the other hand, if you want to take a three-phase connection, so this is phase A, this is phase B, this is phase C, and this is the B. These will draw in a three-phase meter. And then again, phase A, B, C, and neutral. And the consumer to is connected. So now this connection again that connects the distributor to the meter of the consumer is again the service name. This is also known as the SN, known as the service name. So these are the basic three components of any distribution. In the distributor, now let me add something here as well. That is in the feeder हम जो है तो कोई taping या parallel connection जो है तो हम consider नहीं करते थे. Lekin in the distributor we do consider parallel connections. For example, if I take a parallel connection from this distributor, so this parallel connection from a distributor. So if I represent this distributor by D1, so then this will be a distributor D2, and I can connect the consumers to these distributors again. This will be consumer 3. So in the distributor we do take tapings, or you can say the parallel connection. So this was a general discussion regarding the distribution system. Now let us move towards the classification of the distribution system. Classification. Classification of distribution. Classification is basically to classify, or we can say to categorize the distribution system. So now a distribution system can be categorized into three categories. The first is we can say the nature of current that is used in a distribution system. The nature of current. This nature of current can be further distributed into two categories. The one is AC, means alternating current distribution system, and the second is DC, that is known as the direct current distribution system. Now the second category of the distribution system is the second category of the distribution system is the type of construction. Type of construction, and this type of construction can be further divided into two categories. One is the overhead construction, and another is the underground. Overhead Overhead, the type of construction that is used in our country is basically the overhead, means to distribute the electric power to poles overhead. And the second is the underground. Underground. Now I can give you an example of this overhead, the underground distribution example. I can give you like the electric supply distribution in Islamabad. Similarly, you can say in Delhi now. Town. And even in the new city, I think new city phase 2, and the overhead normally you can say the distribution of electric power in Jamilabad in front of the one hotel, the residential area in front of the concerts, or you can say in front of the one hotel, is basically the overhead. Similarly, the third type of classification that we do in the distribution system is regarding the scheme of connection. Scheme of connection. The scheme of connection can be further categorized into radial, second, third, and fourth. The second is known as parallel. Similarly, the third is known as ringman, and the fourth is known as interconnected. Interconnected. So these are the four types of categorization further regarding the scheme of connection: radial, parallel, ring main, and interconnect. Now I will explain all of them. The first type of classification of distribution system regarding the nature of current is basically the AC, whether it is alternating current or whether it is distribution current. We will further discuss in this chapter the alternating current distribution system and the DC direct current distribution system. The second is the type of construction, whether it is overhead. Overhead means through poles. As I have given you the example of the distribution system. In the distribution system, if the distribution system is in the air, means through poles, so then that is the overhead system. And if this is beneath the surface of the earth, then that is the underground distribution system. There are advantages of overhead and underground. Similarly, the overhead has disadvantages and underground has disadvantages as well. Overhead is basically cheaper. I can mention here that this overhead is cheaper, but this is unsafe. Cheaper, comma, unsafe, and we can say untidy. It not looks good. On the other hand, underground system is expensive. Expensive, safe, comma, safe, and this looks tidy. Means this looks good as compared to the overhead. Now, what makes it cheaper and expensive? So there are a number of reasons. Like the underground system needs proper insulation. It needs a lot of digging, and even if the fault occurs in the underground system, it is difficult to to locate. So this makes the underground system expensive as compared to the overhead. So there are a number of reasons, advantages of the overhead as well of the underground. Now the scheme of connection, let me explain this one by one. What does it mean by radial, parallel, ring main, and interconnection? So now let me explain this. The first is radial. Radial. You see, a radial system is something if you connect a load across a single supply. Like I can give you the example of the radial system. For example, if I have the load connected across a single supply, this is known as a radial system. This is load 1, L1, this is L2, and this is the supply. A single supply feeding all of the load. So this is basically a radial system. If, for example, if this supply or anything occurs, if a fault occurs on this line, or for example, if this supply gets out of order, so then the whole load will be in blackout. It means that the power will fail across the load 1 and load 2. Now, in case of distribution system, if I explain, it is somehow like this. For example, if sorry, again. Rail system. I already explained in the rail system. We have a single supply and the load is connected across this supply. If anything happens in this line or happens to this supply, so then it will be back out there in the mode. So you see here in the case of distribution system, here we have a transmission line. And then from this transmission station we have this feeder. And from this feeder then we have a connection to the distribution. You see this is now distribution substation from distribution transformer. And then here, basically, now you see here, in this case, we have a single feeder. We have a single feeder. This is only a single feeder. It is running from the substation. And this feeder, the supply or the load is connected. For example, if it happens to this feeder, one feeder is supply B, but the feeder by B is the load supply. And now these are basically the loads that are connected to this supply. If anything happens to this feeder, for example, if a fault happens on this feeder, now we have to connect this feeder. For example, a fault happens on this feeder, by the length of this fault by A. If the fault happens on this feeder, and if you isolate this feeder, the fault will be complete blackout. So you have to about this, or this is the number of distribution. I can give you an example of this distribution as well. Like this distribution. Like in the distribution system, we have, for example, this is the transmission substation. For example, this is the transmission substation. We have the transmission line terminals. So individual feeders are basically run out of this transmission substation. For example, one.